Welcome back to a new video episode on the series tagged Top 100 Chemistry Calculation Questions. Now, in this series, I'll be solving 100 different calculation questions in chemistry that cut across various topics in chemistry. Now, you can see that we are on the second episode. Meanwhile, I've created a video on the first episode, so you do well to go watch that. Now, let's get into the second episode where I'll be solving from question 6 to 10. Meanwhile, for the first episode, I solved from question 1 to 5. Now, let's get into the video. Question 6 says, calculate the relative atomic mass of oxygen. Now, you can see we have two isotopic form of oxygen. Oxygen 16.8 and oxygen 18.8 with percentage abundance of 90% and 10% respectively. Now, in the look of things, the question is asking us to get relative atomic mass of this element, which is oxygen. Now, this oxygen exists in two isotopic form in this particular question. So we are to get the relative, which is arrow, atomic, which is M, and mass. Now, there's a formula that must be noted whenever you are solving relative atomic mass of any isotope at all in chemistry. But before I quickly write down the formula and explain how it is done, an important concept must be noted. And what is that? It must be noted that the relative atomic mass of most isotope in chemistry is not a whole number. Now, what am I trying to say? It means that whenever we are to solve relative atomic mass of any isotope at all in chemistry, the answer we'll get will not be a whole number. That means the answer we are to get must have points in it. So, in the look of things, without even solving this question, I can actually get my answer without stress. Now, what is the answer? It is simply option B. Yes, 16.2 is the relative atomic mass of oxygen. Now, you can see that 16.2 is the only value here that is not a whole number. That makes it the correct answer to the question. Meanwhile, for option A, 16, option C, 17, option D, 18. Recall, I said that the relative atomic mass of most isotopes in chemistry is not a whole number. So the answer we have to get must have points in it. But let's say we are having option C to be 16.4. That is why you must understand the concept on how to solve this question. Now let's get into the solution to this question. Now, to solve relative atomic mass, there's a formula that must be noted. And what is that? It is simply percentage 1, which I'm going to tell us what each of these parameters mean. Percentage 1 times M1 over 100 plus percentage 2 times M2 over 100. Now, before we start applying all of the parameters into the formula, we need to understand an important concept. And what is that? Let's say this is an unknown atom X, and here is A, and here is A. Now, it must be noted that A has a name. It is basically called the atomic mass. This must be noted. A is called atomic mass. If we don't want to call it that, we simply call it mass number. Okay, if we want to call A atomic mass, we simply call it mass number. And if we don't want to still call it mass number, we simply call it the nucleon number. So all of these are the possible names for A. Okay, atomic mass or mass number or nucleon number. This must be noted. Now, what is Z? Z is called the atomic number. Z is called the atomic number, or we simply say proton number. This information must be noted. Now, what is percentage 1? Let's quickly highlight all of the parameters in the formula, and I'm going to tell us what each of them actually mean. So percentage 1, M1, percentage 2, and M2. So what does all of these parameters mean? Now, percentage 1 is simply percentage abundance of the first isotope. That is what percentage 1 means. Now, what does M1 mean? M basically means mass number. So when we are talking about M1, it simply means the mass number of the first isotope. Anything 1 actually means first isotope. So percentage 2 is simply percentage abundance of the second isotope. What does M2 mean? It simply means mass number of the second isotope. Now, before we start applying all of the parameters in this question into the formula, we have to take note of something. How do we know our first isotope? How do we know our second isotope? Now, we were given two isotopic form of oxygen. Oxygen 16.8 and oxygen 18.8. Now, it must be noted when numbering 16 and 18, which comes first? 16 actually comes first. So this basically becomes the first isotope, whereby 18 becomes the second isotope. So everything that is 1 in the formula should be ascribed to the first isotope, and everything that is 2 in the formula should be ascribed to the second isotope. Meanwhile, they gave us the percentage abundance of both isotopes. Okay, you can see with percent abundance of 90% and 10% respectively. So it means that 90% is for the first isotope and 10% is for the second isotope. So with this information, let's go ahead and solve the relative atomic mass of oxygen. Now, what is the percentage abundance of the first isotope? 16, oxygen 16 by first isotope. So what is the percentage abundance? It is simply 90%. So that is for that times mass number of the first isotope. That's what M1 means. Recall I said mass number is located up. So looking at both values, which becomes the mass number? 16 is the mass number. So write 16 here over 100 plus percentage abundance of the second isotope. It is simply 10%. This is second isotope, so this is the percentage abundance times what is the mass number of the second isotope. This is second isotope and the mass number is 16 and the mass number is 18 rather. So we write 18 over 100. So what becomes the relative atomic mass? It becomes, press a calculator for this we are having 14.4 plus 1. Press a calculator for this we are having 1.8. So when we press the calculator, relative atomic mass of oxygen becomes 16.2. You can see that all of the answers is still option B. Now, it must be noted that whenever we are to solve the relative atomic mass of any isotope at all in chemistry, we must take note of the percentage abundance given in the question. You must actually first of all add the percentage abundance of both isotopes. You can see here is 90% and you can see here is 10%. You have to add. When you add both of them, when it gives you 100%, no, the question is very correct. So sometimes you can just make one of the percentage abundance of the isotope not to be correct. So when you add, it will not give you 100. That means that particular question is not correct. So you have to take note of the percentage abundance before solving. It must be noted that whenever you add the percentage abundance, it must give you 100%. So you are good to go to solve and apply the formula and get the answer without stress. So let's quickly move over to the next question, which is question 7. So let's quickly move over to question 7. Question 7 says, an element X with relative atomic mass of 16.2 contains two isotopes, which are X16 with percentage abundance of 90% and XM with percentage abundance of 10%. What is the value of M? Now, to solve this question is very easy. First of all, when we look at the particular question, we have to deduce where this question is actually coming from the subject called chemistry. Now, in the look of things, this question is from the topic which is isotopy and relative atomic mass calculations. So we are still to apply the formula we applied in question 6. So when I see this type of question, I simply remember the formula, which is relative atomic mass is equal to percentage 1, which is percentage abundance of the first isotope, times M1, which is mass number of the first isotope, over 100 plus percentage 2 times M2, which is mass number of the second isotope, over 100. Now, let us bring out the parameters in this question. First of all, let's write out the two isotopes, which is X60 and XM. So this is what we are asked to calculate for. Okay, this is what we are looking for. Now, from the look of things, X16 has a percentage abundance of 90% and XM has a percentage abundance of 10%. Now, which of these isotopes they mentioned first in the question? It is actually S16. So this becomes the first isotope. So everything that should be 1 should be ascribed to this isotope, and everything that should be 2 should be ascribed to this isotope. So this is second isotope. So what is the relative atomic mass in the question? It is actually 16.2. Now, let us apply all of this into the formula to get the answer without stress. Now, relative atomic mass is 16.2. I simply write it is equal to what is the percentage abundant of the first isotope. This is the first isotope, so the percentage abundant becomes 90%. So here is 90 times what is M1. What is the mass number of the first isotope? It is actually 16 over 100 plus what is the percentage abundant of the second isotope? It is 10%. Okay, it is 10%. So here is 10% times what is the mass number of the second isotope. This is what we are asked to get. So this will be M. That is what we are asked to get over 100. Now, let's evaluate this. 16.2 becomes, when we press a calculator for this, we are having 14.4 plus 10 over 100, that is 0.1. Okay, remaining M. So, when we've gotten this, the next step to take is to CLT. What does CLT mean? Collect like terms. Okay, so whatever are the same, you bring them to one direction. So 16.2 and 14.4, they are looking alike. So basically, 14.4 will come here. So I still write 16.2, and 14.4 here is a positive value. When it crosses the equality sign, changes to minus. So it becomes 16.2 minus 14.4 is equal to only this remaining 0.1 m. So 16.2 minus 14.4, that is 1.8, is equal to 0.1 m. So next is to DBS. That means divide both sides by the coefficient of m. And what is the coefficient of m? It is 0.1. Okay, by the coefficient of m, which is 0.1. So after that, we are having 1.8 is equal to 0.1 m. So divide both sides by the coefficient of m, which is 0.1. I do this. So it cancels. So what becomes m? M becomes 1.8 over 0.1. So what becomes m when press capital? It becomes 18. Yes. So the value of m here is basically 18. So the answer goes to option C. So you can see how questions like this have been tackled. It is very easy. Just follow the steps and you get the answer without stress. So let's quickly move over to the next question, which is question 8. Now let's get into the next question, which is question 8. It says a silicon containing oil has 92% silicon, which is Si28, 5% silicon, which is Si29, and 3% silicon, which is Si30. Calculate the relative atomic mass of silicon. It is very easy. This question is on its concept, which is isotopy and relative atomic mass calculations. Now, whenever we see questions of this sort, we have to write the formula I gave previously in these two questions we just saw. And what is that formula? It is simply percentage 1 times mass number 1 over 100 plus percentage 2 times mass number 2 over 100. Now, in the look of things, in those questions I solved previously, you can see that I always stop here whenever I'm to write the formula. This is because the two questions we just saw previously contain just two isotopes, okay? Contains just two isotopes. Now, in the look of things, I can see three isotopes here. Silicon 28, silicon 29, and silicon 30. That's, I can see three. 1, 2, 3. Now, whenever you see something like this, if you see three isotopes, you simply add it to your formula. So we now have percentage 3 times mass number 3 over 100. So let's say we are having the fourth isotope plus percentage 4 times mass number 4 over 100. So that is how it is solved. Now, from the look of things, let us apply all of these parameters into the formula. So what becomes relative atomic mass of silicon? Now, I told us initially that before we start solving, let us check the percentage abundance. If we add them, let's see, it's going to give us 100. So from look of things, 92% plus 5% plus 3%, that is 100%. So, what is the percentage abundance of the first isotope? This is the first isotope because this is what I saw first. This is the second isotope, and lastly, this is the third isotope. Okay, now let us apply all of their parameters into the formula. So, what is the percentage abundance of the first isotope? It is basically 92% times what is the mass number of the first isotope? It is 28 over 100 plus what is the percentage abundance of the second isotope. The second isotope is silicon 29, so the percent abundance is 5% times what is the mass number? 29 over 100. Okay, plus percentage abundance of the third isotope, which is 3, times the mass number, which is 30 over 100. So what becomes the relative atomic mass of silicon? So let's press the calculator and get the answers without stress. So 92 times 28 over 100, that is 25.76 plus 5 times 29 over 100, that is 1.45 plus 3 times 30 over 100, that is 0.9. So let's get the relative atomic mass of silicon. It becomes 25.76 plus 1.45 plus 0.9. So when we hit the calculator, we are having 28.11. So this is the relative atomic mass of silicon. Now, in the look of things, the answer goes to option C. Now, it must be noted initially, I said that the relative atomic mass of most isotopes in chemistry is not a whole number. So without even solving this question, I can actually deduce my answer. You can see that the one that should be the answer should basically be the value with a point. So looking at all that values, you can see that here is just 0.0, which is same as 28. Here is still 0.0, which is same as 29, and here just 14. So all of these are whole number. 14 is a whole number, 28 is a whole number, 29 is a whole number. So this guy, which is 28.11, has point in it. Basically, that becomes the answer. But when you now have a different set of options, having like 28.25, like that, you have to solve using the formula, and I believe it is very, very easy. So let's quickly move over to the next question, which is question 9. Now let's get into the two last questions, which is question 9 and 10. Now question 9 says, how many unpaired electrons are in the 2p4 orbital? It is very, very easy. Whenever I hear the p orbital, my mind should go to how many boxes I draw for the p orbital, or how many degenerate does the p orbital have. Now, it must be noted, whenever we have to draw the p orbital just have 3 boxes. So whenever we have to draw for the p orbital, it has 3 boxes. Though there are reasons to this, I have a lot of videos I've explained why this works. So for the p orbital, we draw just 3 boxes. And in the look of things, this p orbital contains 4 electrons. So these are the electrons we have to fill in this orbital. It is very, very easy. According to a rule called Hund's rule of maximum multiplicity, we have to fill this electron in the orbital singly before pairing takes place. So I'm to fill first electron, which is 1, 2, and 3. Okay, and the fourth one, which is number 4. So how many unpaired electrons can I see? I can see 2 unpaired electrons. Okay, 2 unpaired electrons. So in the look of things, since I have 2 unpaired electrons seen in this atom, I simply say this particular atom is paramagnetic. So this must be noted when it comes to electrons and unpaired electrons. We say that particular atom is paramagnetic. But if they are paired electrons, we simply say that particular atom is diamagnetic. So this must be noted. Now let's quickly move over to question 10. It says which of the subatomic particle is not found in the nucleus of an atom. Now this question is very, very easy. When I see this type of question, I simply draw an atom. Now this is an atom. I will label this atom. The atom is made up of a centrally located nucleus. This is the nucleus of an atom. And it must be noted that the nucleus of an atom contains just 2 subatomic particles, and what are they? It is protons and neutrons. And it must be noted that electrons revolve around the orbital. So all of these are the electrons. All of these are the electrons. Now, when you look at this atom is actually sodium. Okay, it's actually sodium. Now, moving further, you can see that the question says which of the subatomic particle is not found in the nucleus of an atom. Now, you can see that all of these I'm seeing are called electrons. So which of the subatomic particles will not be found in the nucleus of an atom? It is basically electrons. Electrons are not found. You can see they revolve around the orbital. Okay, that is why a region in space where there's a high possibility of finding an electron is called the orbital, but a region in space where there's a low possibility of finding an electron is called nodal plane. All of these must be noted. So the answer goes to option B, which is electrons. So if you find this video helpful, do well to click the subscribe button and also share these videos with your friends.